Now, if you see this, I was talking about the flange coupling. There are uh, parts, like I said, there are two flanges, one on the left and one on the right. We have two shafts, two keys, because the key will be sitting on the shaft, and we have four bolts and four nuts. Now, the flange will be like this actually. If you see the drawing of one flange, it will be like this. You see there are four holes, and there is inside, in the middle, you will see a hole for the shaft. And you can see there is a keyway. Keyway means there is a slot where you are going to fix the key. So what the key will do is it will hold the flange and the shaft together. Just like, for example, if you want to fix some two parts, you need some threaded element, but key is not a threaded element, so there will be no thread. So key is a non-threaded element. So if the function of a key is to hold the shaft and the flange together. It will be like this. So you see, the flange will be something like this. Now we are going to fix another flange. This is the left flange and right flange. So both are connected. And as I told you, you have a shaft and a key. So the key will sit into the shaft. You already have a slot there. So this will go inside the flange, one side, and the same thing for the other flange. You can see, so one side is rotated like this, the other side is straight. So if you see the drawing, in the drawing, if you see one side, the key and the shaft, it is rotated here, it is down here. But whereas here it is straight, the key and in this shaft and the key in this shaft, you see both are not in the same position, it is slightly rotated. That's the same thing in this video. Now these are joined, these two are flanges are joined with the help of four bolts and four nuts. As I told you, you have four holes, so the other side will be the nuts. Yeah. So when you draw the side view, it will look like this. Almost it will look like this. You will see this hexagon, and then you see the shaft and this key. Now what you see in the drawing is something like this. This is actually the front view, but in the drawing, this is actually, this one. What you see is a sectional front view. And the side view, you're going to draw it using this dimensions. So the dimensions are given for your understanding. Okay, these are the dimensions given in a 3D picture. This is not you're going to draw. This is just to read the drawing for flange and shaft and the key. The dimensions are given. You have to draw what you're going to draw. You're going to draw this figure which is already given. It's like a redraw. So you have to draw the sectional front view. This is sectional front view. Along with this, you need to draw a side view here. Like for example, the side view will come like this. The circles which I have shown you. So when you draw the side view, you will be able to draw the front view. So the dimensions for this, like for example, let me just take one dimension. Like what is the size? Total size of the flange? It is 200 diameter. If you see, the diameter is 200. It means from here to here, it is 200 diameter for one flange. For example, if you see this is 40, see the width is the 40. See this is 40. Means from here to here is 40 for one flange. The same thing for the other one. This is also 40 for this. So this dimension is for one flange. It will be same for the other. Similarly, let us take this shaft size. What is the shaft size? It is 50 diameter, right? It means this is one. This is the shaft, which is 50 in diameter. So this diameter will be 50. So you have to take the dimensions from here, and you have to draw this. Similarly, if you see this diameter is how much from here to here, a part of the flange, it's 100. So 100 means from here to here it's 100, like that. So you have to take the dimensions from here, like this is 22. 22 means this width from here to here. This is 22, and this is also 22 for the other flange, like this. Say this is 75. This is 75 dimension for the width of the one flange. So from here to here it will be 75, like this. And when it comes to the key here, the key is actually a rectangle in shape. So it will be like this. So you see 16 by 10. 16 by 10 means the the width is 16 and the height is 10 of the key. And the length is not given, so we will assume some length of the key. Maybe we will assume, say this is 75, is more than 75, so we'll assume some dimensions which are not given. So let us say the key length is 80, and from here to here it is slightly outside the flange. So the length we'll assume 80 and the dimensions which is given here. Okay. And also the length of the shafts are not given. And this length of the shaft means how long is the shaft is not given. This shaft or this shaft, we don't have the length, so you can assume it like this is 75. So I will take this as 100 from here to here. Let us take the length is 100 from here, and also this is also 100, 100 for the other shaft. So we are going to take the dimensions, and you are going to draw uh, the sectional front view. And after that, once you draw this, you're going to fix a bolt and nut. Bolt and nut we already discussed in the exercise 2.3, how we are going to construct it. We are going to use the same formulas. As I told you, this size, see, in this hole, you're going to fix it. So this hole is nothing but M16. M16 means what? What do you mean by M16? The size of the hole. M16, it means the size is M16. It means the capital D will be 16. Using D16, you're going to calculate the dimensions for hexagon 1.5D, for bolt, the same rules. Like for example, this is bolt, so this thickness will be 2 by 3D from here to here, and this is a capital D, and then we are going to put small d here, thread length, the same angles. This is nut, so this will be 7 by 8D, so everything will be same. And you see the hatch will be opposite for this. When you do the hatch, it must be opposite because this is left flange and this is right flange. So whenever we show it in the hatching and then in assembly, you must show the hatch opposite, just like I have given example in the exercise 3.2 where we did the assembly of cap screw and stud. So we do the hatching opposite so that to identify the parts are fixed. Okay. Okay. Now let me just go back to the exercise. So what we are going to do, if you see the exercise, this is already given. So you have to draw exactly the same. Along with this, you're going to draw the side view. I'll just show you the side view will look like this. See, the side view will something look like this when you draw. So this will be your sectional front view. Okay, and this is your side view from the left. This is side view. This is sectional front view. It is actually not a full section. It is just only a half section. You see the downside there is no section. So we say this is half sectional front view. So you just need to redraw as it is, but along with this you need to draw this side view. So side view will look like this. If you see, there will be circles, okay, and the hexagon. It's used to draw the bolt and nut, okay, and whatever you see. Because if you draw this view, it will be easy for you to project the lines from here, and you can easily draw this sectional front view. I will just show you this one now, and this you can draw. Okay, when you submit, you have to draw these two views. Okay. So let's just me just show you this one, how you are going to draw it. Let me so that you'll have an idea. Just take the some line. Okay. Now, if you see, read the dimension now. We'll try to read the dimension so that I will draw this one for you, the side view. The other thing, this you can draw it on your own. You're supposed to draw the two views. The first thing, let us start the first circle. What is the size of the first circle? The bigger diameter of the flange, that is given as 200. You see that? This is 200 diameter. So I will draw the first circle, that is diameter D 200. So this is my first circle. Okay. Then moving on to okay. Moving on to this one. Next, what is the second circle here? You see there is a small width here. I'll just zoom in. You can see there is a 6 width of this plane here. So 6, this the first one is 200. So 6 is for one side. So other side will be 6. So it will be 12. So 200 minus 12, you will get the second circle. I will show you how it comes. This, I'm going to draw another circle. Diameter 188. 188 is actually 200 minus 12. I'll show you why I'm taking like this. So if you check the dimension between the first circle and second circle, it must be 6. As per the drawing, that's why. So if you take 6 only, it will be 3. So you have to take 12. So 6 is only for one side. So 200 minus 12 is 188. So if you see the diameter of this second circle, okay, it will be 188. The first circle is 200. Okay. Next, we have another circle for the holes. That is a center to center distance for the 4 holes. That is how much diameter is given? 140. So I will draw another circle. Diameter 140. So this is actually the center to center distance. This is where you are going to have the holes. So the holes will be diameter 16. So I will going to draw the diameter 16 here. This I can copy because I need it on the 4 sides like this. Okay. Next, coming to the flange, and this one is 100. Okay, and I will draw a circle of diameter 100. Then we have a shaft that is 50. That is diameter 50. Now this is a flange dimension. But when you fix it, when you finish the assembly, when you fix it, the assembly, you will see the bolt and nut as well. Okay, because you have a hole here, you can see the bolt and nut, and also you can see the keys. There will be 2 keys. See, one is on the top and one is on the right. If you see the external front view, it will be on the right. So how we are going to see? First, we'll take the hexagon. As I told you, we'll draw the hexagon for the bolt and nut, because when you are going to draw the front view here on this side, you need this hexagonal bolt and nut, that is hexagon, to draw the bolt and nut. I'll give the hexagon number of sides 6. Now this is the center. Now, as I told you, we are going to use the same formula, that is 1.5D. When you draw the hexagon, the rule is same, 1.5D. The D is how much? As I told you, the D is 16, M16, the whole size. So you can calculate how much will be the 1.5D. The 1.5 multiply 16, it will be 24. So 24 is a width, so radius will be half always. So you must remember that. So I'll give half of 24, that is 12. I got it. Then I need to draw another circle for the hexagon. But now, if you see, we are not going to draw the hexagon, the bolt and nut vertically. We are going to draw horizontally this in this direction. So you must rotate this hexagon. Just like last week we have rotated, depending on the direction. So I'll rotate it. So I see I have rotated. So when you see the dimension, the width 1.5D will be 24. You can see there. Okay. Then you will be able to draw the lines. You can project the lines from here. Okay. Or if you feel difficulty, you can copy the same, put it in the same straight same line, and then you can project the bolt and nut here. When you draw for the sectional front view, it will be easy for you to draw the arcs by projecting the lines on the other side. The same thing I need it on the four holes. I will copy this and I'll put it on four holes because I need it. Because we have four bolts and nuts, so it will look like this when you fix it. We have another circle here. If you see, we have one more circle which will be hidden, which is not visible from this side, from the left side. That is this one. There is a slot here, if you see, and this dimension, I will show you this dimension, which is here. This one, 90, which is given. This is actually a slot at the back. If you see, this is a slot from here to here. It means from here to here there is a slot here, but this is not visible. This is because it's only a section on the upper side, half section. So we have this is 45 and this is 45. So this is actually 90, which is already given here. So this circle will be visible. Sorry, hidden. It will be hidden. See, 90 diameter. So I will draw that as well. Diameter 90, but this 90 will be hidden. Yes. Just remove this one. So now I will draw the keys. As I told you, when you fix the key will be here for the this side, okay, and the other key will be on the other side, but that will be hidden because it is onto the right side of the flange. So if you see from this side, from the left side, you will be able to see only one key, okay. The other key will be hidden, which is on the right side. Okay? So one key will come here at the top, another key will come here, this side. So this will be hidden actually because this is for the other side at the back. So I will draw the key. The dimension, as I told you, it is 16 by 10. So 16 will be the width and height is 10. So you see how I'm going to draw. I will just take a line, straight line. Because if you see the key is actually the element which will hold the shaft and the flange together. So it will be half inside the shaft and half inside the flange. You see the drawing? The key is see half inside the flange and half inside the shaft. Here also, if you see the front view, exactly it is half inside the flange and half inside the shaft. So it will be, that's why it is exactly in the middle. So I'll take 5 because the height is 10. Okay. And the width is 16. So I will take 8. So it will be something like this. I can just trim it. remove the extra lines. Also this one. I will also trim this. Okay. The keys, you can see the dimension. The length of the key is 16, and the the thickness, that is 10, 16 by 10. Now usually this will be the same thing on the other side, but that will be hidden. I'll just try to copy this one and put it here, but this will be vertical because it is not in the center. Let's move that exactly. Should be exactly in the middle. You can exactly move around the dimension. It will be something like this. But this will be hidden completely because it is uh, for the back side, for the other side that is on the right side. So we are going to make it hidden. Let us put hidden like this. Similarly, this one, because this is inside the shaft, it will also be hidden because you cannot see that. Only the one side. Just something like this. This is also hidden. So now this is your complete side view from the left, complete. Along with this, like this, you are going to draw. Yeah, somewhere. The side view will come here, what I have drawn here. Along with this, you are going to draw the sectional front view, which is already given in the exercise. So using this dimension, you're going to draw it. What is that? Yeah. First you draw this one, it will be easy for you. Then it will be easy for you to draw the front view, this side, the sectional front view which is given in the book, in the lab manual, using the dimension. So once you draw this one, it will be easy for you. Like for example, you can project this line here to draw the front view. Also, everything you can project it. For example, I want to draw bolt and nut, so I can project it. You already have this one. So the flange, like this. So everything you can project and you can draw. Similarly, if you see the dimension here, you can make it half. Like for example, from this is 40. So this is 40 from this side. You can say this is 40 and this is also 40. You can offset like this. Say the length of the shaft, I'm assuming 100. 100 is my length of the shaft. So I'll take 100 from this side, 100 from this side, like this. This is 75. So from here, this is 75 and this is 75. Okay. So that is, okay, let's go back to the numbers. Okay. So for this exercise, remember you're going to draw two views. One is the sectional front view, that is which is given exactly, all right, and then the side view from this side, which I have already shown you. Any doubts?
No, teacher, it's clear.
Okay. So you can submit this exercise next week. That is week number 7. I have given one more day extra, so maybe on 12th or 13th you can submit this exercise. Let me just take the attendance. I'll just take the attendance. Lab section 3.
Teacher, and we draw the side view, right?
You have to draw two views.
Yeah.
Okay, side view and the front view, which is already there in the book.
Okay.
So I need two views here. It's like I explained here. I need two views. One is this one, already I've shown you. The other one is the side view, the circles which I have drawn you for your understanding. Actually, this is actually redraw. So you have to take dimensions from this 3D picture and you have to draw two views. Actually, in the book, it is given three views. If you see, read the question, you draw the front view, top view, side view. But we need only two views. Front view that is given here. Along with this, you draw the circles. Okay, two views.
Okay.
Okay, just taking attendance. All right. Okay, 144 Turkey. Turkey Al Ansari. 155
Yes.
329
Yes, 329. Yes.
399 Ahmad Saad 399 638 Ibrahim 638 291 Khalid 291 041 Husam.
Yes, teacher.
Okay. 087 Abdulaziz.
Yes, present.
372 Ahmad.